All right. Hello, ACT Prep Kids. I'm back again to go over a few of these challenge questions from numbers 21 to 30. The first question, it seems like we had trouble with as a class, and probably the most trouble was number 23. So I'm going to start with this one. Um, I know that you've had me for geometry algebra. We haven't talked a lot about chords. A chord in a circle is simply a segment that connects one side of the circle to the other. So this would be an example of a chord. You could also have a chord that's something shorter like this. You could also have a chord that goes right through the middle, etc. The key point here is that they tell us that the chord is 5 inches from the center. We always measure to a chord the perpendicular distance like this, and it's going to bisect that chord. So in this particular case, the 5 inches from center tells us that this piece right here of this triangle would be half of 24, which is 12. So now this becomes a basic Pythagorean theorem problem to solve. We're just going to do 5 squared plus 12 squared equals r squared. 5 squared is 25, 12 squared is 144, and the radius squared. Remember that in this triangle, the longest side of the triangle is the hypotenuse, and the hypotenuse is what we're trying to find. So we have to make sure that our variable r is in this point of our equation. So let's continue to solve the equation I've got written out here. 25 and 144 is 169 is equal to the radius squared. We would square root both sides, and r would be equal to plus or minus 13. In this particular case, since we're talking about a length, obviously the only answer here would be the positive 13. So the answer to this problem is D. The next question I want to take a look at is this spring length and force application. This actually reminds me of more of a physics problem, but this is actually just solving a basic equation. So we know that in this equation right here, a couple things to pay attention to. L is the length in meters, so we want to make sure that our units match up. So it tells us that length is in meters, and we're given this measurement here in meters. So that checks out. The next thing we want to look at is what F represents. F is force in newtons, and it's asking us what force in newtons must be applied. So our units for F also match up. So what I'm going to do here is I'm just going to plug in the given information into this formula. So the length of the spring is 2/3 times the force applied plus 0.03. We know in this particular case, we're trying to find the force, but we know the spring has been stretched to 0.18 meters. So the length is 0.18 from this given information right here. And that's going to be equal to 2/3 times F, which we're trying to find, plus 0.03. So we can solve this basic equation, subtract 0.03, subtract 0.03. Here's an example of maybe some math that you might want to be able to do without using a calculator just for efficiency and speed's sake on the ACT. 0.18 minus 0.03 is 0.15 is equal to 2/3 times the force. We want to obviously figure out what the force is, so we have to get rid of this fraction. This is absolutely a key concept. The best way to clear a fraction is to multiply by its reciprocal. So I'm going to multiply this side over here by the reciprocal of the fraction 2/3. I also have to then multiply this side over here by that same reciprocal. What happens on the right-hand side is 3's cancel, 2's cancel. So we can see that the force that we're looking for is equal to 3/2 of 0.15. 3/2 is 1.5. If I take 1.5 times 0.15, I'd look at that as 15 times 15, which is 225. So our answer here is H, which is 0.225. So the force required would be 0.225 newtons. The next question I want to take a look at is number 26. This is also a question I had some concerns and comments about. So let's take a look at how to do this. There's actually a couple different ways. The first thing I want to do is review these trig functions. It's the old acronym SO for sine, CA for cosine, and TOA for tangent. O represents opposite, H represents hypotenuse. Remember, the opposite and the adjacent sides can vary depending on what angle you're working with. The hypotenuse in all of these formulas has to be the longest side of your triangle, and that longest side is always going to be opposite the right angle. So opposite and adjacent, these two will vary, opposite and adjacent will vary based on what reference angle we're using. Remember, for trigonometry, our reference angles are the two acute angles and not the right angle. So opposite and adjacent are going to vary based on that. Just after that review, now we can take a little look at this problem more closely. So I'm going to erase some of this stuff. We don't need any of that. And let's go ahead and look at what it's asking. It tells us the hypotenuse of the right triangle is 16 feet long. I've got that highlighted already. The sine of angle P is 3/5. Now, a couple different ways to do this. One thing we could do is we could look at a different right triangle. These sine ratios are consistent. So if I drew another triangle like this and made this angle P, we know that sine is opposite over hypotenuse. And opposite over hypotenuse in this case is 3/5. So basically it's telling us that the opposite side P has to be 3 and the hypotenuse has to be 5. Now, once we have this picture, we could just do similar triangles. We could say that 16 is to 5 as x, that's what we're trying to find, QR, is to 3. And if we cross multiply here, we'd have 5x is equal to 48. And when we solve, we're going to end up with dividing by 5, and we end up with 9.6. That's the correct answer. So there's one way to do some trig using similar triangles. Again, your ratio for opposite to hypotenuse is always going to be consistent no matter how much this triangle grows. So you can see going from this triangle to this triangle, we obviously grew, but the ratios are going to stay the same. So 3 to 5 is going to be x to 16 based on that given ratio right there. Another way to do this would be to use our inverse trig functions. And I want to show you this just to kind of give you some background information and help maybe spark your memory a little bit. We know that if we have a sine ratio of 3 to 5, so basically what it's telling us is that in this triangle, the ratio for this angle is 3 to 5. If we want to find this angle right here, if we want to find an angle, we can use sine inverse. An inverse trig function will allow us to find a missing angle. So at first glance, this is actually how I did this problem. I don't know if it's faster than using the similar triangles method, but this works well too. So the sine of P is 3/5. The sine inverse is going to give us this angle. So if you type sine inverse of 3/5 into a calculator, and your calculator is in degrees, you're going to get 36.86 degrees for this angle right here. Now we can use that given information along with this idea that the sine of an angle is equal to opposite over hypotenuse, and we can just plug in information. We know that we're dealing now with the sine of 36.86 degrees is equal to opposite x over 16. So opposite x, hypotenuse 16. We know this angle is 36.86 degrees. Now, based on using this inverse trig to find this given angle, now we only have one unknown in this equation, and we can solve for x by multiplying by 16 here, multiply by 16 here, and we end up with 16 times the sine of 36.8 degrees. Again, we're not using sine inverse because we have the angle now. The only time you use sine inverse is to find an angle, as we did right there. So again, type this into a calculator, 16 times the sine of 36.86, and you get 9.6. Answer is G. All right, the last question I'm going to take a look at in this segment is number 28. I was actually surprised that this question caused some trouble, but let's take a look at kind of the quick way to do it and what it's actually asking. I'm guessing that's kind of half the battle, is trying to figure out what they're asking us to do. So what they give us here is they give us the equations of two lines. Hopefully you recognize that y equals mx plus b and y equals mx plus b are both lines. Just a very quick sketch of this line right here. We have a y-intercept of 6, so 1, 2, 3, 4, 5, 6 y-intercept. and it's got a slope of 2. So we're going to go up 2 units and over 1 unit to come up with another point. So just very quickly and roughly, this line right here, I just circled in red, would be something like this in our coordinate plane. Let's sketch a quick graph of 3x plus 4. 3x plus 4 is going to have a y-intercept of 4. 1, 2, 3, 4. This is going to go up 3, 1, 2, 3, and over 1, something like this in here roughly. Now, all it's asking is at what point, or what is the x-coordinate of the point at which these intersect. So we know that they're going to intersect at some x, y ordered pair, and this question is asking for what is that x value. Now, in this diagram, you might be able to look at that diagram and figure it out. My drawing is actually not necessarily to scale, and a lot of times the equations you're given aren't going to be easily graphed like that. So by far, the best way to do this problem is just to take these two lines. We're talking about the red line and the green line, and we want to know where they're equal. And where they're equal is the spot that they intersect. So we're just going to take the two lines, 2x plus 6, and we're going to set it equal to the other line, 3x plus 4. We're using algebra to show exactly where those two lines intersect and where they're equal. So if we solve this, we're going to subtract 2x from both sides. You're going to have 6 is equal to x plus 4. We'll subtract 4 from both sides, and we get x is 2. This is actually a great learning point about the importance of checking your work and doing the work via algebra versus wasting your time on this graph. If you understand what the question is asking, then all of this stuff right here graphically isn't really necessary. We can save a lot of time just by setting them equal and solving. So the answer is x equals 2, which is B.